we are all very eager to hear from the great scientists from NASA we have today. Respected chief guest of today's function, Dr. Sachidananda Babu.
What is it that GRSS can do? What is it? Some of you may know what is remote sensing. Some of you may not know what is remote sensing. I'll give you introductory slides to show that, and also to show that when you see a big satellite mission, you don't realize that how much work has gone behind that. Starting from a simple thing like a small part has to be developed, and how the development takes place and how it evolves over time. This involves both sides of my work that I have done in NASA, having worked on building big missions, satellites like James Webb Space Telescope, which is the biggest, and the smallest ones like these CubeSats that we have launched to do Earth observation. So the whole spectrum of it I've worked over the years, and I'll give some, at least a flavor of it, that you will see what has been done.
Maybe quickly you can cover the life cycle of how the satellites are designed and the process quickly.
Like I told you, the most important thing, first thing is that the technology. One thing is that we in NASA, in US, we have National Academy. National Academy publishes every 10 years decadal survey. And in the decadal survey, earlier they used to say exactly this kind of mission you have to do, this kind of mission you have to do. But since last one in 2017, what they did is that this measurement is important, this measurement is important, this measurement is important. So when they said the measurements, then what happens is that at that time, we know which technologies are needed. And it so happens that we at my office, we always have technology. We don't look at 10 years.
We have to search the NRSA, National.
The Hyderabad.
Yes, is that also that we connected with all this?
They take a lot of the data from. They are responsible for taking the data from ISRO and distributing that. Their job is, but also they do take NASA data also. They do have a ground station. They do receive the data from NASA satellites, and NASA satellite data is distributed to them also. Phytoplanktons are the ones which generate close to 60% of the oxygen that we breathe today. If they don't exist, if they don't produce the oxygen, Earth will not be habitable anymore. So we have to look at their health, and we have to see how we don't affect their health. So remote sensing comes in very important there. So you can see here, this is the color. You can see that chlorophyll, all these things. You can. This was a picture that was taken by PACE spacecraft, and you can see the color differences. How you can classify different phytoplanktons and chlorophylls and things like that. And this is one interesting one, phytoplankton bloom in Gulf of Oman. You can see that how green color this is blooming. That means that it is producing a lot of oxygen there, and that is what is needed for us every day. So as you can see, that a most important thing that we have to do is that connect it to human life.
What spectrum of light, whether the infrared, NASA generally uses for remote sensing?
From you can take from 1 micron, that is the short wave, all the way to 12 microns, 1 to 12 micron. Air quality, that's very important, because you hear every day in Bangalore how air quality is, and in fact there are I've seen on the road a couple of places air quality monitors are there, and the big display boards are there. So this is very important. We study from space. This is a micro scale, or we study in a universal scale how it is changing.